Today's topic is on trustworthy large language models and ethical AI. So some really pressing topics that we're excited to dive into. So without further ado, I'm going to hand things off to our first speaker. And so it's my pleasure to introduce Rheeya Uppaal. Did I say your last name right? Uppaal, okay. And so Rheeya is a second-year CA's PhD student at the University of Wisconsin-Madison, where she collaborates with Professor Junji Hu. And her research focuses on building reliable language models that are truthful and aligned with user-defined standards by intervening on a model's internal architecture. Additionally, Rheeya is interested in developing techniques for language models to generalize to tasks and domains with limited or no supervision. And I'll also just mention, outside of the lab, Rheeya is collaborating with myself and others in the carpentries community to distill some of her complex machine learning knowledge into an accessible workshop that can help people learn about trustworthy AI and methods you can take to avoid things like toxic embeddings. So let's all give Rheeya a warm welcome.
Can everyone hear me right with this? Okay. Yeah. Thank you for the introduction. And also a big thank you to all of you for showing up despite, it being the end of the semester. So kudos to motivation here. Today I'm going to be talking about some of our ongoing work on trying to basically make language models less toxic. This is a fairly interdisciplinary team here. We have people from computer sciences, statistics, and biostatistics who've all put our heads together on this project. So let's start by taking you through a bit of a play, perhaps. Just talking a bit about language models. We know that they're everywhere. We see examples of them where companies are actively looking to replace certain professions with automated LLM agents. People are now designing entire degree programs designed just towards learning about LLMs. They're becoming they're being taken into use so much that their problems like hallucination, which previously used to be very research-only things, are actually affecting the real world. And today, people are actually wondering if, models like ChatGPT are going to replace Google search. Also, this article was written by ChatGPT.
Yeah.
So we know that they're everywhere, but can we really trust them just yet? Probably the answer is no, but we don't really have a good understanding of how to really go about this. We know that they're not totally safe, but we don't really know how and why and where and how do we make them safer. So we're going to touch base on that a bit today. Currently, the best method towards trying to make models safer is basically trying to align them towards human preferences. So how many of you here are familiar with these terms, RLHF, DPO, or have at least heard of them somewhere? Okay, some people. So it's a really simple idea. We start off with our original language model right here. And we say, okay, we will have the model generate some text, send it off to a human being who will then say, okay, this particular, series of text that was generated by the model didn't sound really good. It was kind of unsafe. Give it a low score. This one sounded really safe. It's helpful. Give it a high score. So a human being goes around labeling a whole bunch of data. And then that is used to train something known as a reward model, which is basically the replacement for a human being. So now this reward model essentially says, okay, given any stream of text, I can give you a score for how human preferred or unpreferred it is. And finally, given this reward model, we loop it all back into the original model saying, okay, let's train this model to now try to optimize for, getting really good scores through this reward model all the time. Basically, if that, the schematic, it took me a while to understand it when I looked at it the first time. So the underlying idea here is just that we want a model to generate text that's more similar to what human beings like. So that's basically what the RLHF algorithm is. DPO, which is a nifty modification of RLHF, essentially follows the same principle. It just does some cool maths to delete the reward model from the procedure, but the underlying principle is still the same. Now, the issue with these methods is that whole process of having a human being go through a whole lot of data, it's pretty expensive because it's not a really simple labeling task. A human being has to actually read through long paragraphs of text to see, is this safe, is it not? It also is prone to a lot of issues with labeling because, labeling can be subjective. Maybe the person who was annotating the data was sleepy that day. We don't know. And let's say even you've got access to this huge, large, wonderful data set. Do you necessarily have the compute to train on it? And let's say even you have the compute for that, do you really know whether this whole process of aligning your model has actually done what you wanted it to do? I think probably common news articles will tell us that the answer to that is no, because we have seen a lot of evidences saying, oh, if you give ChatGPT this kind of prompt, it's going to tell you how to make a bomb or whatever unsafe information there is, which basically just points to the fact that these types of training-based algorithms, like the RLHF thing I showed you here, is basically, it treats the whole model like a black box. So we don't necessarily know whether it's actually learning what we want it to, or it's just pretending to learn that while still keeping track, while still remembering all the unsafe information it's not supposed to keep. So as an alternative to this, there's this new class of approaches known as model editing, which showed some promise. So how many of you here are familiar with or have heard of model editing? This is definitely more obscure, so I'm not okay, wow, I was not expecting even one hand up. Okay, so basically, the idea of model editing is that we want to mimic the procedure of training a model without having to actually train it. So essentially, we want to do some kind of deterministic operation on the weights of the model or the embeddings of the model to kind of, after that operation, it should behave as if the model had been trained on, a particular data set or something. A really popular approach towards this is very geometric. So if you would imagine a particular weight, like one layer in your neural network, that's basically just a really high dimensional matrix, right? So that essentially you could think of being a vector in a really, really high dimensional space. The moment you go with that analogy, you can actually start thinking more about what these weights are representing. So like here, this work developed something known as a task vector, saying that, okay, if you think of a pre-trained model as a point in this high dimensional space, and your fine-tuned model is another point, the vector, which is just the difference between them, essentially encodes all the information that you would have gained by training on this task. So essentially what this is saying is that you can actually, there are certain directions in the overall space of weights of a model which encode information about a task. Okay, great. So what? It's nice to know that tasks can have certain directions, but we try to break that down further, saying that, okay, if let's say our task was, let's be simple, sentiment analysis. You were trying to see if some text had a positive or negative sentiment. That's maybe our task, but that task itself is composed of multiple different facets of information, multiple different features. So can we maybe break down that one vector representing the task into these smaller vectors, which each represent a feature? Essentially, can we decompose said vector into its components? And you can. A lot of these features don't make sense, but the interesting thing is some of these features actually correlate with properties that are human interpretable. So for example, a lot of recent work has found features which correlate with the things we care about really. So truthfulness, harmlessness, and so on. So what people do is they say that, okay, there are different ways of finding what these directions are. But let's say someone found this direction and they said, oh, this is the direction which represents truthfulness. And we want to make a model less likely to hallucinate. We want it to be more truthful. What do? We know this direction exists. We say, okay, if the model's embeddings were naturally going in this direction, let's just push it a bit in the direction of this truthfulness. And so that would just be like simple vector addition. And now the new embeddings are, as unintuitive as it may seem, are actually more likely to make the model truthful. I'll pause here real quick in case anyone has any questions, because this is like a very out there concept. Yes.
I'm wondering if there is a difference between truthfulness and harmlessness.
That's a good question. I think the difference here would be in truthfulness. Maybe the answer to something may not be harmful per se, but the model may get it wrong. So if I said, who is the president of the US? The model may give me an incorrect answer. but that's not necessarily a harmful answer. Versus something where maybe, someone's asking for information that might be potentially used for some kind of negative if task afterwards, if that makes sense. Okay. Yeah.
Could in the higher dimension vector, could the element which corresponds to truthfulness be different depending on the topic that you're looking at? Like, say you're looking at truthfulness in biology versus truthfulness in politics.
Yeah.
Could the element which you're adding that feature truthfulness to be different, or do you think it remains the same?
Yeah, that's a good question. I think it depends to an extent on like what are the domains you're dealing with. So if they are, I don't know, let's say political news and financial news or something, probably there will be an overlap in those directions. But if you go really far off, like maybe to medicine or something with biology, there would be lesser of an overlap. And that is a caveat with these approaches as of now. Yeah. So that's an active area of research.
So you have to kind of do the dimension feature extraction. I see.
Yeah, I think the assumption is more that you'll use this model for this downstream task. So in that task, let's identify what are the properties we care about, align it to that, and then move on. Yeah. Okay.
Yeah, I have
okay.
a follow-up question. So how do people find the features? Do they manually find the features or train the model to find out the features?
Yeah, so it's normally an automated process. There are many different approaches of trying to identify these features. In fact, what we'll be getting into is one such approach. But normally, one popular method is that, let's say we're doing truthfulness, we'll have the model train a linear classifier on the embeddings of the model to identify truthful versus not truthful information. And essentially, that linear classifier is going to be separating hyperplane of all the truthful embeddings and not truthful embeddings. So then that can be used as a direction to represent truthfulness.
Okay, so train the model using a particular data set to find out the truthfulness feature.
Essentially, yes. Of course, the idea, thankfully, we do have data sets that, for truthfulness, for example, which are fairly generous. So finding them based on that one data set can be used for a fair amount of use cases.
Thank you.
Yeah. I think you also had a question.
Yeah, that was basically my question. How are these interpretable behaviors mapped onto the features or vice versa?
Right. Yeah, I'll definitely be getting into more details. So within a few slides, you still have that question, please yeah. Anyone else? Yeah.
Maybe look into this, but I'm wondering if you can clarify what exactly you mean by direction here. Are you looking at individual neurons and whether or not they activate, or are you trying to look at this as a pattern of activation across all the neurons? And that's kind of the direction.
Yeah, it's basically not at individual neurons. So I think a lot of research has recently shown that information can't really be stored in just one neuron. So it's really hard to localize to saying, okay, we'll just look at this part of the network. So this is actually saying that we look at all the activations from layer L of the network collectively, maybe across a whole data set. And that's what is that one vector. Okay. Also, feel free to stop me for questions anytime. You don't need to wait for me to pause. So yeah, essentially now we're trying to push the activations or weights in these favorable directions that we like. So let's now maybe wrap that into what the main project of today is about, which is trying to reduce toxicity in a model. So we follow a really similar principle. What we try to do is find out what all the toxic directions might be out of all those different features. Essentially, all the combination of all those features builds out a subspace. So once we find that subspace, we try to work on weights instead of the activations. And we say, can we actually project the weights out of said subspace? Is everyone here familiar with what a projection is on an intuitive level? Okay, in case any of you missed it, imagine that there's just a line here and another vector here. A projection of this is basically just like the shadow of this line onto this one. So that's a projection onto a plane. And what we're doing is a projection away from it. So kind of the opposite to ensure that shadow becomes zero. So what we're saying is basically, let's identify all these toxic directions, and then let's change the weights in such a way that the weights absolutely do not point in any of those toxic directions anymore. So what we basically do here is say that we pick out the embeddings from the model. So what we do is take out these reference data embeddings. So we have like some toxic statements, some non-toxic statements. We take the difference of those, and that's essentially, that matrix can be considered to be a vague approximation of this direction towards toxicity. But toxic text does not just, swear word after swear word. It's also actual language. It has, common English words. It has actual syntax we care about. So it has some information that we don't want to totally delete from the model. And that is basic. So let's say we work with if you take this reference matrix, which is this difference of embeddings, and we just break it down using SVD. So we have different components. What we think of the first component here, we say is basically all the standard information which just exists across language. So really common stop words, punctuation marks, things we are not toxic at all, but are common between toxic and non-toxic text. We do not want to touch this. Furthermore, within this, there'll also be semantically useful information, which here we're denoting as a contextual subspace. And then finally, you have these toxic directions, which combined together form this toxic subspace. So what we're trying to do is say that, okay, we have this reference data, positive embeddings, negative embeddings, we get the difference of them. And then from that, we try to fit, from all the directions that it contains, we try to filter out the ones that are only toxic. And once we have this, what we do is build out something known as a projection matrix, which basically it's just a simple idea saying, okay, once you have those vectors, you do some fancy stuff. And when you multiply that into the weight, it basically projects the weight out of said subspace. So what we do here is we have a transformer model, which has ML. So basically the feed forward layers in the transformer models are known to contain they encode the actual concepts and information in the model. So those are the parts that we actually try to edit. So essentially what we do is say that, okay, we have this particular matrix over here. We take out whatever the embeddings are from right after this. Using that becomes that matrix. We calculate what are the toxic directions, apply the projection on said weight to edit it, and we move on. Does that make sense, or that's kind of obscure? Okay. Yeah, I can pause for a moment if anyone. Yeah, go ahead.
Yeah. So when you talk about projection in the linear orthogonal projection, but the one concern is that for example, if you are training classifier, classification function might be nonlinear. So you project out to the complement of the toxic space. Does that be helpful to deal with a nonlinear classification function?
So in this case, this is being basically applied not at the final layers of the transformer, which actually does the classification, which is basically the classification layer. This is being done through all the intermediate layers of the transformer. And there, the only function of those layers is essentially to just develop informative representations of the text it sees. I'm not sure if that answers your question.
So,
yeah.
Do you do this in the training stage or after the training?
So yeah, editing basically involves no training whatsoever. So we pick up an off-the-shelf model.
So after training, you're editing the base.
Yes. And this is just a one-time operation. We're done. You can, continue using the model as many times as you want after that.
I see. Thank you.
Yeah. I'm happy to answer more questions offline if you're still confused.
Yes.
Yeah. Yes.
I'm sorry. What is MLP?
Yeah, I'm sorry. I should specify that. So basically, a transformer layer has these two major blocks. So the first one's called a feed-forward neural network, which is the most standard basic neural network architecture. That's also known as an MLP. And then the second thing is the self-attention, which is quite specific to transformer architectures. So essentially, the MLP here has two feed-forward layers. The second one is the one which we call MLP value, is the one that's essentially encoding all of the concepts and information within the model. So that's the one we really target to edit.
Sorry,
yeah.
Say again. So you are editing all the weights across the whole model?
No. So basically, firstly, we're not touching self-attention at all, because that basically focuses more on how to process information between different parts of the sentence. the MLP layers are the ones which are actually, they're kind of like the knowledge stores of the model. So that's where concepts like toxicity and so on are encoded. So we're only targeting those. Furthermore, we're also only doing this on the second half of the model. So we don't touch the bottom few layers because we've noticed that those are the layers which typically try to, like the layers that are trying to learn more basic information about how to develop sentence structure, really basic semantic concepts. And then these more abstract things like toxicity, harmfulness, and so on, they start coming up in the higher layers. Any other questions? Okay. I also see we're not doing very well on time, so I'm going to skip the one slide you shouldn't have listened to anyway. But yeah, I'm happy to get into this in detail offline in case any of you are curious. So this approach, we call DeTox. The cool thing is, so we compare it with the alignment algorithm from a few slides ago, DPO. The cool thing is that it works comparably to DPO in terms of reducing toxicity, but it is way more sample efficient. It needs far less data to achieve similar performance. So what you're seeing on the plot in the left here is we take this really popular language model known as GPT-2, one of the old ancestors of ChatGPT. And then we see, okay, originally, what was its toxicity? That's in the yellow bar here. And its perplexity, you can just think of that as a vague notion of how capable the language model is. So after doing like DPO, which is the alignment-based training, toxicity reduces, great. If you do that on 500 data points, you do that on the full data set of like 20,000 data points, it reduces further, awesome. But then you do this edit with just about 500 data points, and it kind of echoes the performance of having to train on way more data than that. And then here we do the same thing with a large language model, so 7 billion parameter model. And see the same thing essentially with just like 50 data points. The model does really good compared to DPO with like 5,000 data points. And the green bars here you see are just like another measure of capability of the model, so you don't need to focus on that too much. And yeah, okay, in the interest of time, I'm going to skip this as well. So one cool thing is, despite the fact that, this edit works at a way more sample efficient way compared to DPO, they still are kind of trying to target the same thing. So what you're seeing here is basically a graph that is just comparing the ratio of similarity between the edit approach and the gradients from the DPO algorithm. Basically, all this is saying is that as we move up the layers of the model, a really good fraction of the DPO gradients, which is basically saying what is the information DPO is trying to teach the model, can be really well explained by the direction, the toxic directions that we discover in the edit approach. So essentially, this is just pointing to the fact that they're trying to achieve the same thing. But the interesting thing is here that as the number of samples increases, that's when DPO actually starts getting similar to our edit method. So you can essentially think of that to imply that the edit method with very little data is kind of achieving this one, great objective, and DPO needs to hit a really huge number of data points before it manages to achieve said same objective. And another cool thing is that this method, unlike DPO, is also really robust to any kind of noise in your labels. So this is a really common setting that I've seen is that, if a human being is annotating some data, they see, they're trying to say, oh, this is harmful text, this is not harmful text. Sometimes the labels get flipped over and the non-harmful text is marked as harmful and vice versa. So we try to simulate that situation here, saying basically on the x-axis, we flip around with saying, okay, let's look at the original data set and then gradually start flipping all the labels of the data. And what you see is that the toxicity of DPO starts increasing quite a bit, which is natural. If you tell a model to say, oh, try to be toxic instead of try to not be toxic, obviously it's going to have higher toxicity. But the cool thing here is we do not see that with the edit approach. And that's just because we're not trying to identify what is a direct, we use our data to just identify these directions, and those directions do not change regardless of what order you use your data in. If that doesn't make sense, I will be happy to talk about it after offline later. I'm sorry, I'm just looking at flying right now. But yeah, just to zoom back a bit, I think the main drawback of our method as well as editing in as a whole is that one, it's really, really hard to achieve this perfect balance between finding directions that are toxic while absolutely without having any information about stuff that we care about. So if we go back to like this slide, it's really hard to pick out these directions which are purely toxic and don't have any information that's actually related to, useful knowledge or syntax. And another thing is that, so basically, if you do pick out some information that is syntactically helpful, what you can do is break the model through the edit. So it'll become non-toxic, but it'll also spew out complete garbage, which makes no sense. So it's a little hard to evaluate for whether you have truly broken the model. If you've made a very obvious break and the model is just like saying absolute nonsense, it's very easy to pick up on. But what if the model has generally behaving fine, but then in this one obscure setting, it suddenly breaks down? You need to have really thorough evaluations to ensure that that it's not going to happen even in those like really rare corner cases. And yeah, the final part of the talk is up to you guys. So thanks for listening, and I'm open to more questions.
Let's say that towards the end, it's not so easy to separate one of the attribute truthfulness and maybe some other attribute, let's say toxicity. So is it possible to have the same effect that we want, let's say we want to cancel out by doing the same weight editing operation a little earlier in the neural network? So not going so deep in the network, but still deep enough so that language understanding is there, but maybe trying to clip the weights in some earlier layers instead of going all the way where we can't be sure. So that may still have some effect, but is it possible to have the same editing operation by doing it a little bit earlier?
So if I understood you correctly, you're basically asking if doing an edit on the earlier layers of the network instead of the later layers would somehow be easier to isolate the toxicity, right? So unfortunately, the thing is that these early layers of the network are actually really crucial to general language understanding, because those are the parts of the network where the model's still understanding really basic things like syntax, it's learning vocabulary and stuff like that, which is very, very important for every function that the model needs. So typically what we've noticed is that if you do any edit on those parts of the network, it definitely breaks the model. So basically we work only on the later layers because that's where concepts start emerging as separate entities. So it's somewhat still easier to disentangle at that level. Does that make sense?
Yeah, the question was about from that layer onwards, like when it has a language static, but the room in between. Have you tried layers?
So you're saying like from when it starts encoding concepts?
Language
Huh?
From that.
Okay, I don't think I completely understood your question. So you're saying like, let's say at layer 15 is when this understanding.
Yeah, and let's assuming that you're doing it this at layer 20. Is it possible to have layer it earlier so that it will be easier to separate them out?
We have tried that. It doesn't really work. And also the issue is that we're working on models that have already been trained. So essentially, even if like basically the functionality of every layer is pretty much fixed. So even if we do an edit on an earlier layer, the later layers won't necessarily be able to adapt to our edit. Does that answer your question though? Okay. Any other questions? Yes.
I'll try to make it quick, but like, do you think there are issues fundamentally of doing some sort of linear projection when you're dealing with a neural network, which is doing non-linear computations? Like, is it going to be fundamentally perhaps impossible for it to do weight editing in this way to remove all the toxicity?
I think it would be impossible to remove all the toxicity, but that might be more because of the whole entanglement of toxic and non-toxic information. Because interestingly, a lot of work, as unintuitive as it may seem, has shown a lot of relations between like these directions correlate between activation space and weight space. Because and a lot of the nonlinear operations, at least in terms of these directions in the embeddings, do not seem to make much of a difference, as strange as that sounds. So that's why I think people are also able to treat like weights and activations equally, because they say, oh, the activation is just like a weighted combination of the weights. Yeah, but I think there's definitely like a more principled understanding in that is very much wanted.
It seems completely valid. I'm just wondering about those limitations.
Yeah, I mean, it empirically works. People don't know why. I think that's the short answer.
How do you, maybe you explained it at the beginning, but I'm still not clear how you evaluate how you can evaluate what is toxic and what is not toxic.
Yeah, no, that's a really good question, and I should have covered that in more detail. Essentially, toxicity in at least the NLP research world is defined in it doesn't have a very, very clear definition, actually. The general notion is that if you give a model some kind of prompt of text, which could be a normal string of text, it doesn't need to be anything toxic, the model continues it by adding a lot of expletive words, extremely offensive language, it being generally rude, that kind of stuff. So that's basically how we evaluate here as well. We give it if phrases like, oh, she's so full of blank, please continue the phrase. So if the model follows up with the words we don't want, then we mark it as being toxic.
But how can you automate that? Because language is, a word that is offensive in one circumstance may not be offensive in another circumstance.
Yes.
You have to, can you automate this, or is it still some human involvement to clarify the toxicity?
Yeah, that's a good question. I think you're very right about the fact that the different words can vary a lot based on what context they're in. So I think people generally have like a general automated solution, which don't necessarily look at all the nuances, but are generally good enough. So what people do is they've taken a bunch of toxic text off the internet and trained these neural networks to be able to classify and quantize how toxic they are. So what we do basically here is, once the model has generated whatever the text is, we just send it off to one of these automatic scorers, which then tells us how toxic that generation was.
Okay. Yeah, thanks.
Okay.
Like Rheeya.
All right, thanks so much.
So next up, we have Mariah Knowles, my former colleague, and now works at Tiny Earth in the public. So Mariah is a PhD student in the iSchool, and today she's going to be sharing some work from her PhD. So I'll give her a warm welcome.
Yeah, I'm Mariah Knowles, she, her, hers, PhD candidate in the information school. I'm going to share some early results from my dissertation. Oh, there we go. But before I do that, I'd like to start with activities in these talks. So imagine that you're a student in a large 300 student class. The class is an in-depth class that covers AI ethics issues, moral theories, how to put ethical principles into actual practice. It's the spring semester. Several of your friends that you've made this semester are graduating seniors. You work together on many projects. They're engaged, well-read, know how to follow the guidelines and put it as they develop simple models, like everything we just heard in the previous talk. But the past few weeks have been stressful and bittersweet. You'll likely never see each other again as you all go your separate ways. Applying to jobs has been a slog as you write one cover letter and resume after the next. Older friends that you made when you were freshmen have been posting online recently about getting laid off. And in any major city where there are jobs, there's also a housing crisis. So as the last lecture of the course comes to a close, you overhear your friends joking in that half-joking kind of way. Oh, I'll just go do evil for money. This comes from real experience. In pairs at your table for 3 minutes. I'm actually going to time us. How would you feel in this scenario? And how would you respond to the group of students if you were their ethics teacher? And if you're on Zoom, feel free to post in chat. So 3 minutes. I hope this warm up resonated with you. My entire talk, I hope it resonates with you. That's my reward signal. All right. So if I had the entire hour, I would like have y'all share out, but I heard some of y'all go, ooh, this happened to me. No, this is based off of an actual student conversation I overheard teaching a large 300 student ethics class. But my research, my dissertation aims to understand the experiences of social change and becoming good, whatever the heck that means, as an AI practitioner, as well as the moral aspirations at play in that, or like, as I've been doing my dissertation work, I've thought of just the tightest way to explain it is that scenario that happened to me and going, how would I respond to that dejected ethics student, right? And so that's going to be my focus just for this talk. So study has 4 phases. We're currently right here in the middle where I'm at the part of officially sharing out early results before I go and start conducting follow-up interviews and then close things out. So I conducted 10 interviews with AI ethics practitioners and teachers that lasted about 90 minutes each, produced 800 pages of automated transcripts and 80 pages of memo notes, including this book I have in my hand. And across all that, looking for the emerging concepts in my memos of what would be the cool stuff to talk about in the dissertation, I found 41 concepts. So my data is a big pile of text. Kudos to Chris for finding a really good pairing of talks that talk about interpretable text in vector spaces. The neat math thing, no, I'll get to that in the next slide. But my memos, I mentioned I had 80 pages of memos. One genre is handwritten notes, right? But I don't hate myself that much. So I did also type up some notes in a Google Doc in like a table, right? Going very slowly through parts of interviews and writing up what I saw and why it mattered. And also just recording myself on Teams and hitting transcribe, right? So I have a few different media that I worked in. And going back and rereading those as I am, going through the many layers of qualitative analysis, I like right away noticed the concepts that came up and the ways that they came up vary depending on the media I worked in. And then my like quant background kicked in and went, well, hang on now, how would I control for that effect? And so that's this talk. Right, is how can I model what concepts are nearby in some meaningful sense to other concepts, controlling for the effect that the memos were written in. And so I'm through and through a mixed methods researcher, even when I really try not to be. I end up going there anyways. And so as my job as a mixed methods researcher, I say that I'm here to just tell a rich qualitative story whose turns are guided by quantitative features. So what I did is I manually labeled every sentence of my 80 pages of memos. Let's say taking the motivations one, identify, just like I just automate identifying a window during which it occurred without like leaving for a bit. So it's kind of always in topic for what we're talking about at the moment. Count up all the other concepts going on in that window, do this for all windows for that code or that concept. Label what media type this is in. My emojis looked better in my copy of this, Chris. I don't know what you did. Accumulate this up and sum it for every media that concept occurred in, and then repeat that for all combinations of concepts across all media. And the general approach to this for more, go see Quantitative Ethnography by David Schaefer. The result of this is a vector space. Thank you for setting us up for vector spaces. I have one vector per concept plus media, right? That's the pairing. I find the mean of every concept group. So if these 3 vectors are, or these 3 are the same concept in different media, I'd find their mean, right? I then do a dimension reduction that maximizes the between concept variance, right? The between concept mean variance, and the result is similar to PCA or SVD, but controlling for or reducing some amount that effect of the media difference. Then insert your favorite way of picking how many dimensions to keep. The elbow method does well enough for this, and I've done a lot of qualitative inspection of the results and say that's about where I'm getting good results. In that reduced space, I do some hierarchical clustering, and I chose that for a number of reasons. One being that I could explain it to my advisor, who's a lawyer and not a quant person. And the version of this clustering method I chose is one that produces a very sensible order for concepts, right? I could start on the left, tilt my head, fix my plot so my labels aren't cut off, and just read down it and kind of get a sensible understanding of what's going on in the concept, kind of moving in a gradient from one idea to the next. as I look at the data manually, again, on several layers of rereading the same data, and also look at a heat map and see where there's still some strong connections across, like not near the diagonal, the interpretation of the data, the complexity of the data is a little bit more than just read down a list, right? There's other connections going on. And so to help me just, like, I hate heat maps. These don't tell me anything. To help me see the heat map, I like making a network that kind of shows like one kind of slice of it. So for every concept, I connected it to its nth percentile nearest neighbor and tweaked the n so I can kind of see different levels of density of connections, and then use these together to start rereading as I tell a story, right? I thank you for setting us up with the act metaphor too. So yeah, as I tell this story, my goal is to seek coherence between all the different models that I have, qualitative and quantitative, of this same analysis. But it's been 9 minutes of me talking. So what do you predict I saw in my results, right? I spoke to practitioners and teachers about their AI ethics, views, and experiences. I'll give you another minute and a half to chat with your neighbor what you predicted my next few slides are going to be. And thank you for the question that I really wanted to answer. So the question was about sampling bias and whether people held back their politically incorrect views while I talked to them. They didn't. Oh boy, I had this one interview that went 2 hours long, and I just sat there in awe. So yeah, no, they did not hold back their politically incorrect views because they thought I agreed with them. I have a face that looks like I agree with you all the time. Cool. Let's check your see if we have the same ideas. So I'm going to start on the bottom part of the network here. I'm actually going to check my notes to make sure I didn't forget stuff. The one way I might respond to that dejected ethics student is by beginning here in the lower part of this network and setting some groundwork for some groundwork clarity about what the job of doing AI even is. Right? We talk a lot about hypotheticals in school, but you get out in the world, it's like freaking messy. So talk about like the scope of work, how we put the principles into practice, the previous talk, thank you. And then the things that drive and motivate it, from capitalism and just profit to being in a space that values solving fun engineering puzzles, being in a space like healthcare where the grand challenges and missions are what driving us. Then I might jump up the top, do some groundwork, talking about what it means to collaborate on a team, to reflect on your role within a team, to have a job in the first place, what it's like to communicate with people who are in different teams or in different fields or have different backgrounds or so on, and having to come up with or really lack a shared language about what the word graph means. Right? I used code by accident earlier when I'm trying to say the word concept, right? Because I'm in a space where code has 5 different meanings. And one participant had this really cool point that documenting your models is a moral practice because no one in the world is going to think more deeply about that model than you did, because they're not going to train it from scratch. They're going to do something else, right? And so writing down all the weird edge cases of it is your moral duty. Then I might move to the complicated feeling of belonging in tech. And like no one feels like they belong a lot right now, especially graduating seniors in a world where like a lot of social change around AI is happening. There's a lot of uncertainty and housing crisis and the world's on fire. Canada's on fire again. If you saw the air quality report again this morning. But specifically within tech, right, we've got these pressures to keep up to date with like very complex technical knowledge. How many people didn't raise their hands earlier during the talk? To also have this high moral bar that we feel like we have to meet all the time, right? A lot of like the social change work is being offloaded onto AI ethics researchers to go, okay, I'm going to do the tech part and you make sure that I do it good. You know, that feels weird. And then there's this concept of that there's a right professional. Hi, Alan. This is moral. Sorry. There's this concept of this right professional trajectory that you might be in, right? That the right way to make it big in tech is to go to a good college, go to a CS program, get top like scores on your exams, and then go get hired by Google. But not a single person I interviewed went through that, right? Everyone has their own wildly different trajectories in life, and those trajectories actually inform them and enable them to do the work that they do. You should read this memoir by Ellen Ullman. It's one of my favorite books, and it really goes in depth into all the feelings in this theme. Then even having the chance to put all this stuff into practice is a bit of luck, that your employer will make time for you to document your model the extent that we might want, or to do any of the number of best practices that we keep coming out with, right? Instead of just moving on to the next project, you might not have the luck that your employer or your higher ups buy into any of this, right? Anything else on that? Oh yeah, I heard a ton of horror stories about people who do like explicitly AI ethical work being laid off, right? Or people going, I'm going to not do that because I've seen so many people be treated poorly because they were trying to do things in like a morally right way, or trying to follow the best practices we're told to follow and stuff, instead of just get the job done, you know? But you might not be lucky, but you can still do take everything you've learned from these AI ethics courses or these conversations, or reading the guidelines or everything, and be a mentor, help others around you, whether it's stakeholders or the next people coming in or so on. Be able to think and reason about AI ethics issues clearly, right? The other thing that you can do is act with integrity. This is a huge, I like that it's vertical, and it gives it a sense of bigness to it, right? Act with integrity, understand, keep an eye on the news and cases and so on around like AI law that's emerging and stuff. Understand how the issues apply at scale. That's some of the stuff I was hearing a little bit over here. Keep an eye on the kind of the institutions in society that are impacted by data and AI are changing, right? And privacy and all those things change with them, and avoid buying into the hype, right? To not let the hype of what systems can do distract you from actually understanding on the ground how it works. Also, just a quick note, as I was putting these slides together, I noticed two parts of the story deal with communicating, and I find that a neat parallel. So when you're thinking about how we communicate with others in a team and so on, it's pretty small scale. We think about like your role within a team and so on. Whereas earlier I mentioned like being a mentor and so on, that's a larger scale to me, right? It's something that spans generations. It's something that requires tons of empathy as you deal with stakeholders, people who are impacted by power systems and so on. And I'm gonna actually flip to my notes on this one. I did my first pilot for this dissertation back in 2020, which was a great year to do anything. And I've heard constantly since then the stories of students or professionals or someone who just want to put their head down and churn out good work, ignore all the talk about ethics and morals and so on, and just be a cog in the machine. And what I want to say with this one single code by itself before I move on to the last chunk is that it's okay to want to churn out good work, right? That's an okay motivation to have. We all want to add value to what it is that we have spent our last 4 or 8 or 7, or I've been in college for over 12 years, right? Training to become an expert in. It's okay to want to have value that you get out of it. Let's see. But at the end of the day, the way that you do, I'm going to say capital G good in your own way is going to be up to you, right? The way that you be good is up to you. And that's a really quick way to say, I wish I had more time to unpack that, but we're already at time. So maybe I'll do another ML+X talk or something, unpacking that one theme. But my closing activity would just be, if you were the student who half joked, oh, I'm just gonna go do evil for money, and I, the teacher who spent the last 2 years figuring out how I would respond to that student, responded this way, how would you feel? We have time for a minute. Yeah, okay. I'll give y'all another minute and a half. So I'll unpack that moment. The student was joking, right? But also dejected about how hard it is to all of this stuff I've said about like the world being on fire and housing, and sometimes you just have to make money. So what do you do? And it's like, well, you know, I don't want to be like hope's lost, hope's just complicated, you know. If you want to talk more about evil, come to the Evil Reading Group. It's an acronym, but honestly, I picked those letters because it was funny. It's our AI ethics reading group. We meet every 3 weeks. I don't know if we're meeting over the summer, but we definitely will meet over the fall. I'll come back to this if you want to scan it for the QR code, but sign up so you can give me your input and I can pick dates around your opinions. Thank you. This is my cat.